Hi, welcome to the notes for the second day of H5-1. Yesterday we started finding the inverses of algebraic equations, and you did it by listing out the order of operations and then doing the reverse order. Today you are going to focus on a second method for finding the inverse of an equation. Okay, when we do this one, we are going to use an algebraic method. Okay, and then we're also going to determine if functions are inverses using composition of functions. Okay, so let's go ahead and get started. This one says find the inverse algebraically. Okay, so that's what we're focusing on here. Now you can always go back and check it using the method we did yesterday, but there are two steps to make this work, and they're pretty easy. So the very first step, if we're going to do this algebraically, is we are going to switch x and y. Okay, so we're going to literally switch x and y in our equation. So when I do that here, and I'm going to show you that first step, I've got my equation, y equals 2 times the quantity of x minus 1, and that's being cubed. Okay, and remember, if it's an f of x, right, if you have an f of x in any of the problems, f of x is the same thing as y, so you can always swap it out and make it y if you see an f of x instead of a y. But I'm going to switch this to x, I'm going to make this y, and I'm just rewriting the rest of it in there. It's x equals 2 times the quantity of y minus 1 to the third power. Okay, and then the second step we're looking at is we are going to solve for y. Okay, so we're going to solve it for y. We're trying to isolate the y in the equation. So now we're trying to get this by itself. And we'll go ahead and demonstrate that, right? So if I'm trying to get y by itself, right now it's inside grouping symbols. So the first step we're going to need to do is we're going to need to get rid of that 2. So we're going to divide each side by 2. We now have x divided by 2 equals the quantity of y minus 1 to the third. Now to undo that third power, we're going to do the third root, or the cube root. We'll take that on each side, which gives us now the cube root of x divided by 2 is equal to y minus 1. And to get rid of that 1, we're obviously going to just add 1 to each side. And that is going to get us the cube root of the fraction x divided by 2. And then remember, that plus 1 is outside, and that should equal our y. And if you want to write it in like our inverse form there, you can add the little negative 1 up there. Remember, it's not really y to the negative first power. That just denotes that it's the inverse. So we have the inverse of our function is going to be the cube root of x over 2 plus 1. Now we can still take values and plug them in to check it, right? So if you want to do that right now, you can. For time's sake, with this video, I'm going to not show that step here because I wanted to show one other thing. So if you focused on this equation, okay, at the start, if we focus on that and you think about what you did yesterday, our original steps, right, our original steps for the order of operations would have been subtracting 1, raising it to the third power, and then we would multiply by 2. When you think about the inverse steps, okay, what we did here, right, is we're going to undo this one first. So this would be like divided by 2. Then we would do the cube root, and then we would add 1. And if you go back and you look at what we did, right, the first thing we did here when we were solving our new equation is we divided by 2 on both sides. So there was that one. And then we took the cube root of each side. You see that? And then we ended up adding 1 at the end. So you see how those steps relate to solving it algebraically. Let's try another one. So this example, y is equal to the square root of an x minus 2, and then we're going to add 3. So remember, first step, just go ahead and switch your x and your y. And now we are going to solve it for y. And again, y is inside the grouping symbols. So I'm going to go ahead and subtract 3 from each side. So I have x minus 3 is equal to the square root of y minus 2. Next, right, we need to get rid of our square roots. We're going to square each side. So we now have the quantity of x minus 3 squared is going to equal y minus 2. And then our last step, right, we're going to add 2 across, and we're left with x minus 3 squared plus 2 is going to equal our y. So we'll go ahead and write that in the inverse form, and we'll say x minus 3 squared plus 2. Okay, now, this one is a special case. I want you to go ahead and put a little star here. We'll talk about this after we do the next lesson, okay? But this one is going to have what we call a domain restriction. Now, I know I had you mark some things yesterday too, star some things in your notes there that we're going to come back to. We'll come back to this as well. This way we know which problem I was talking about when we come back to do it. Okay, this answer isn't complete yet. It does require a domain restriction, and we'll talk about that after we do some stuff with graphing in the next lesson. Okay, but if you can get to this point here, you're on the right track. All right, so then we have one more example here for you. F of x equals 10 times the 7th root of x plus 8 minus 4. And remember, just treat this like it's y at the beginning there. Go ahead and flip them and solve it. If you want to pause it, work it out without me going through it there, and then fast forward, you're welcome to do that, see if you get the same answer. I'm going to go ahead and start now. So I've got x and y. I'm switching them. I'm just recopying everything down. Make sure you're careful about what you write out when you're recopying it. Okay, if you're hung up and not sure what to do, think about using the method that we would have done yesterday and list out your steps and then go backwards. That's always a helpful method if you need it. I'm going to go ahead and add 4 to each side. So I've got x plus 4 is equal to 10 times the 7th root of y plus 8. Then we're going to divide each side by 10. We now have the x plus 4 all divided by 10 is going to equal the 7th root of y plus 8. Now we need to get rid of that 7th root, so the inverse would be raising it to the 7th power. So, those of us that write out our steps there, it makes it much easier, and there's way fewer mistakes when we do that. And then we're going to subtract our 8. So I'll just go ahead and rewrite it up here so there's some room. We're going to have the x plus 4 all divided by 10 raised to the 7th power. And then we're subtracting 8, and that is going to equal our inverse equation. And you're welcome to plug something in there if you need to check it.